Hello and welcome to Sean White's Solar and Energy Storage Podcast. The title of this podcast is the new UL PV listing 61730, replacing UL 1703 for making the PV module test work around the world, and the UL 3741 listing for Rapid Shutdown, which is more formally called Hazard Control Systems. And this podcast is, of course, with the world's famous Bill Brooks, PE. That's professional engineer. That means he took a really hard test. So, in this podcast, we're going to talk about that new UL standard for PV, and it's replacing 1703 with 61730. One way to remember that is 1703 is in 61730. They added a 6 in front of it, and they swapped the 3 and 0 at the end, and that's how you got it memorized. So is it memorized yet? And this took place in December of 2020. That's the new listing taking place in December of 2020. You can still use UL 1703 just if you come out, but if you come out with a new module design, it needs to comply with UL 61730, which makes things easier since it is the same test around the world instead of having to do a different test for the US and Europe, for instance. And then another very popular topic that we're going to cover right now is the new UL 3741 Hazard Control System. That means Rapid Shutdown standard, which is another way of complying with 690.12 Rapid Shutdown in the 2020 and 2017 National Electrical Code. So you can perhaps now have up to 3 modules in series after shutdown. That's 2 more than the 1 that most people are doing. We might be seeing these things called mid-circuit interrupters. Those are MCIs on every 3rd module, which is maybe all you need for rapid shutdown, as long as it is a UL 3741 listed solution. This is big news and a new way to deal with rapid shutdown. An MCI is likely to be a switch that does not do maximum power point tracking, like your optimizers, or otherwise known as DC to DC converters, or you can have maximum power point tracking with a DC to DC converter that does 3 modules at once. Either way works. So you better listen carefully to this podcast. In fact, you better listen to it 3 times in a row. That's your assignment. To have fun and learn more about solar and storage, go to Solar, SEAN, that's SolarSean.com. And on with the show. Let's talk about the new PV module UL listing.
Yeah, I'm on the UL 1703 STP, which covers all the standards related directly to PV modules, which would include the new 61730, which is based on the IEC standard 61730. Basically, almost 1703. There's always a 6 in IEC standard, and that's
a little dyslexic there, but
yeah, exactly.
It's a way to remember it, I guess.
Easiest way to remember it. And I think there was a problem with 1703. 61703 was a standard already existing in the IEC, and that's why they dyslexicized the 3 and the 0. The standard actually started in the United States, went to Europe, was adopted, and then came back to the United States. So it was based largely on UL 1703 originally, and then did get modified for the European market, and then in an attempt to have international standard that would work everywhere, including the United States, they just basically brought it back. So it's just taken a long trip around the world.
Round trip. I guess what I get out of it is now they don't have to double test everything. It works here and in Europe, so they don't have to have the CE and the UL and all that. All it is kicked in December 4th, 2019. If you had a 1703 module that was tested after that, it wouldn't work if it was only 1703 technically, but
well, it basically says they can continue to apply the listing. It's just that if you bring new products after that date, then you would have to come up to the new rule. That's essentially the date where new products have to meet the new requirements. So you could continue to build a product that was built to UL 1703 indefinitely, but you couldn't make changes in it.
So we'll see how quickly NABCEP changes their test question, because they love having that 1703 on their associate exam.
Yeah, it's kind of the fact is trying to remember these standards numbers is really pretty silly in my mind. It's what I do day in and day out, so it's second nature. But to actually require or expect people in the field to remember these standards numbers or anything like that, it's just silly.
It's like testing somebody on long division or something.
Yeah, it's just whatever, and you can always Google it.
Okay, so now here's the other one that everybody's been waiting for and talking about. This is the PV hazard control. So this is the new method. It's not a new method. It's even in the 2017 NEC, but they never came up with the standard. And so now they do have a different way besides module level shutdown and the BIPV method is this method, and it would have to be listed to 3741. And so when are we going to start seeing these products? I know that it just came out.
Yeah, so there are several products already listed and certified to this PV hazard control standard, even before it was official on December 8th, 2020. Tesla was probably the first, and they really needed this certification for their power roof product.
Well, isn't their power roof product even complies with like the no metal parts?
It can. They're older versions, but their newer version, not so much. Their newer version has metal flashings and stuff like that, and so I don't think that's really something they wanted to stick with in the long run anyway. That third option, which we call option 3, for not being near grounded metal and stuff like that, is likely to go away in the 2023 code. So we're just going to have two options, the UL 3741 option, which we're talking about now, which is just barely hitting the streets, and the 80 volt option that says that after rapid shutdown, within 30 seconds of rapid shutdown, the array can have no parts of it that are above 80 volts.
Module level.
So in most cases it would be module level. That's been talked about as a module level control.
I was at a Tesla training a few months ago, and they said it was rapid shutdown, but they were putting 3 modules in series. So is that what we have going on here?
Yeah. UL 3741 says that if you've got certain safeguards and all, you can have up to 160 volts available in the array.
So that number's in this standard 160 volts?
No, it's not actually officially. It's in the annexes with some examples. And so depending on how the system is put together, there's a variety of ways of meeting the requirements. It's pretty involved. But if you have a product that's 3741 listed, then it's going to include all the information of how it has to go together in order to achieve that listing, including any electronics and things like that. And they typically all require some level of electronics. So there are what they call mid-circuit interrupters, MCIs. And those mid-circuit interrupters, instead of being on every module, might be on every other module, every third module, every fourth module, depending on the voltage. So you got to remember with the Tesla Powerwall, it's not a standard module at all. I mean, its voltage and current characteristics are dramatically different than typical modules. And so how many you put in series parallel is just how many you put in series in parallel, come up with the right voltage for the inverter.
So 160 volts, what if 80 volts is one module, 160 is 2, but maybe 3 sometimes?
Could be 3 in some cases.
In a warm place?
And so it really depends on a lot of things.
I guess.
And so again, that's just a generic number. So if you run the numbers and you do all the analysis in 3741 and you have electronics, let's say a microinverter, an N-phase microinverter, it's very likely that N-phase and Solar Edge, with their DC optimizers and N-phase microinverters, they're going to come up with a solution that has a 160 volt maximum. And they're going to get it listed to UL 3741. And it'll tell you that you can put 2 72 cell modules in series, or maybe even 3 60 cell modules in series, and run it into this device, and it does everything that needs to happen. And you can use as many of those as you want on the roof.
I was talking to our firefighter friend Matt, and he was saying something about like they did some testing on the resistance of a wet fireman.
Yeah. In the 3741 stuff, yeah. Yeah, so they did lots of testing to determine what would be hazardous and things like that, and what stipulations you'd have to put on it. And it even gets into the electronic safeties of the equipment and all that kind of stuff. So there's a lot that goes into the whole process. And so we're going to see the major manufacturers of products probably all go to 3741 as a compliance option. It doesn't mean that there are other products, they can't use the 80 volt, but there's going to be financial benefits for these higher voltage compliance options.
So say that you are doing 360 cell modules in series now with these things. Do you think they're going to do maximum power point tracking for 3 modules, or just have it just be some kind of off switch?
Well, for instance, for DC optimizers, no question they'll be doing max power tracking.
Yeah.
For the 3 modules.
Is there going to be a cheaper way, though, that some string inverter company is going to use? Or is maximum power point tracking just the way to shut something off?
Yeah. If all you need is a switch, the SMAs of the world will be using a switch. Again, the mid-circuit interrupter. And all it is you tell me how many of these things I can put before I have to have a switch, and we're done.
Is that what they're going to be calling them, mid-circuit interrupters?
Yeah, that seems to be the language that I see on plans and stuff like that. Delta Electronics, for one, has built one mid-circuit interrupter, and I'm sure SMA will come out with one. And
A mid-circuit interrupter, is that something that's already out there for other kinds of electronics, like DC to DC converter?
Well, it's not called that. This is a switch. It's basically, think of a mid-circuit interrupter as an on-off switch that is electronically controlled remotely.
So it's like a contactor.
Well, it's almost certainly going to be a semiconductor switch, not a contactor. A physical contactor would have other limitations that might be problematic in an array.
How would a semiconductor switch work? It won't have a chance of getting a spark going?
Yeah, so there are lots and lots of semiconductor switches. Transistors are all semiconductor switches. We can take a transistor and use it as a switch. And so that's what these devices are. And you want to keep the losses low and all that kind of stuff. So anyway, these mid-circuit interrupters are going to become commonplace, and it'll be the 3741 will tell you how much voltage you can place on each circuit interrupter.
I can't go buy one of these right now yet.
Oh yeah, no. Delta manufactures and sells it right now.
I mean, I can't buy something that's UL 3741 right now.
Oh yeah, you can. So Tesla has a system that's 3741.
You can't buy that.
I believe that
Tesla.
Delta has a 3741 solution, I believe.
But does this have to be like that 3741 solution with Delta? Does it have to be a Delta inverter then?
Yes. In that case, I think it does. And so the question is, will other manufacturers be able to employ Delta's solution? And I believe that I have seen in plans other manufacturers using the Delta product. Now, you could use the Delta product on every single module and meet the 80 volt number, no problem. Nobody would have any trouble with that. That would be a code compliant process. If you want to take advantage of any higher voltages, then 3741 is your friend, and that's the way you're going to have to go. But people are going to use other methods, and we'll see.
How robust do you think these mid-circuit interrupters are going to be? Like, I know that people complain about having to replace things on roofs. Are these things going to be replaced very often?
Well, I can tell you that it is going to be less reliable than a connector.
Sure. Yeah.
And connectors have their problems,
because you're going
right?
to have a connector that goes with it anyway.
Yeah. And so connectors have their problems, and this is much more complex than a connector. And I think where the problems are going to lie, and we don't really have enough experience right now with these things. I've personally run into problems with applying these module level switches and stuff like that is in all the communications.
Yeah.
So we have a SunSpec communication protocol that basically allows these things to communicate through power line carrier. That power line carrier process is not necessarily the most reliable method of communication, particularly if there's lots of noise on the DC side and things like that. So this is not a panacea. It's not a, slam dunk. Mid-circuit interrupters will have their benefits for using primarily with string inverters, but it doesn't mean that they're going to blow away the DC converter market or the microinverter market, which still together make up 80% of the residential market.
Sure, yeah. I just know that the big argument that some of these inverter companies have against module level electronics is they need to be replaced. So you have a third of the amount of equipment up on the roof that's doing a lot less because it's not doing maximum power point tracking and all that kind of stuff. So maybe it will break down less.
It might
Only
break
time will
down
tell,
less.
but when you buy the first version, it won't.
Right, exactly. And I think there's going to be early growing pains. Always has been with new products, always will be. I don't even want to give these guys any press, but there's a movement afoot on the internet to fix module level shutdown devices and stuff like that. And they're claiming that the NEC's the problem, and that's a bunch of BS.
I think I know what you're talking about. I interviewed a guy.
They're very misguided folks. They don't understand what they're talking about. And the problem is in the standards. Problems are not in the National Electrical Code, and putting the requirement off in the National Electrical Code is not the way to fix the problem. The way to fix the problem is go into the standards and say, okay, we have a DC noise problem in our PV systems. We've known about it for decades. And now it's a real problem because we're trying to do arc fault detection and we're trying to do communication on these circuits. And unless you have some standard for what happens on that DC circuit, all bets are off on whether or not you're going to be able to communicate. The SunSpec Rapid Shutdown standard is absolutely at the mercy of the noise level that's on that DC side of the system. And the way to fix it is not to do away with the requirement. The way to fix it is to actually deal with the DC environment. Fix it.
Maybe it's how the sunspots are interacting with the contrails.
That's right.
Now that you know everything, thanks for listening to Sean White's Solar and Energy Storage Podcast. To find out more, go to Solar, SEAN. That's SolarSean.com.